All right. Before we continue with the law of sines and the law of cosines, which we started talking about yesterday, just a few things. We do have a couple of grades left. If you turned in your unit project, that'll definitely be recorded as a test grade. We're going to have another Happy Minutes tomorrow. Remember, everything needs to be taken care of by Thursday morning. If that's a retake, or if you want to do a corrections for an assignment, or if you still have the previous assignment outstanding, all that needs to be taken care of by Thursday morning at 8:05. We're going to end the week with the district assessment, just like I talked about yesterday. If you are a junior in IB and you're going to be taking an exam this year, you do have to pay the registration fee of $172. Does that apply to anybody in here? Okay, so it applies to one person. Okay, so talk to Ms. Moore about that. You can pay the whole amount, or I believe it can be paid in installments if necessary. But let's see where we are. Okay. Yesterday we did several examples over the law of sines, and it seems like everybody was doing pretty well with those. We are still going to be working with right triangles, but for this lesson we're going to go ahead and shift away from them and look at oblique triangles. That means a triangle that does not have a 90-degree angle. So your triangle is either going to have 3 acute angles, meaning smaller than 90 degrees, or 2 acute and 1 obtuse. Okay, so one angle is going to be larger than 90 but smaller than 180. And we talked about, connection to geometry. The large, or the uppercase I should say, letters are going to be your angle measures. The lowercase letters are going to be the side lengths, okay, always opposite each other. And here was the law of sines. The sine of angle A divided by side A equals the sine of angle B divided by side B, which is also equal to the sine of angle C divided by side C. So you were just setting up a proportion. And remember, you had to have what we called a what? A pair. So what is that? What does that mean? There you go. You have to have not only an angle measure, but you also have to know the side length across from it in order to use the law of sines. Now, if you don't have that pair, that is where the law of cosines is going to come in. Okay, and we talked about some patterns yesterday. Whatever side length you're going to begin with, like if we start with side A, then I'm going to end my formula with the cosine of angle A. Okay, it's always going to end with the angle opposite that side you start with. And also, whatever side you start with, it's the other two that you're always going to manipulate. You're going to square and then take the sum of those other two sides, minus 2 times their product, times the cosine of the angle that we just talked about. How far did we get with this one? Did we finish it? So we were almost there. We only wrote it out. Okay, so let me go ahead and catch up to you guys real fast. We were talking about a triangular area of a lawn, talking about we want to know all 3 angles that the sprinkler heads need to rotate in. So the one thing about the law of cosines, see here, I cannot use the law of sines because I don't have what we call a pair. I have all 3 sides, but I don't have any of the 3 angles. Now, if you're going to use the law of cosines, okay, a really good idea, okay, probably 9 times out of 10, is to start with what angle? The biggest. Always start with the biggest, because that largest angle, he could be obtuse, or maybe he turns out to be acute. Okay, but you always want to start with the largest angle, and I'll go ahead and explain why. So I believe yesterday we had this 24.3 squared is equal to 19 squared plus 21.8 squared, that's squared, minus 2 times 19 times 21.8 times the cosine, bless you, of B. That's what we had yesterday. Did I already rewrite it? Okay, because the thing about the law of cosines, I mean, it looks like it's a really big, complicated equation or formula, but really, if you just manipulate it correctly, you plug it all in the calculator is what's doing all the heavy lifting here. You're really not doing a whole lot when you get down to it. The 2 individual terms, we're going to go ahead and subtract those guys over. Once we've done that, that product coefficient we have for cosine, I'm going to go ahead and divide by that. So we should have this. 24.3 squared minus 19 squared minus 21.8 squared, all divided by that negative 2, 19, 21.8, and that should equal the cosine of B. Is that where we got to yesterday? Okay, good, 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 good. Now, let's go ahead and find a value for this ratio right here. So let's just plug the whole thing in the calculator. So control divide. Let's see, 24.3 squared minus 19 squared minus 21.8 squared. This is all over the negative 2 times 19 times the 21.8. Okay. So this is what equals cosine of b. So we get this decimal. So let's say 0.2967. Okay, so I'm going to come back over here. Usually when I'm doing these inverse functions, I like to go ahead and round it to about 4 decimal places. But the number you round it to really doesn't matter. I'm going to show you why in just a second. What was that, 2967? So 0.2967 is equal to the cosine of b, right? Well, we've seen before, if we go ahead and plug an angle measure into a function, a trig function, what am I going to get as a result? What's the output? The sides of what? Well, depending on the ratio, but it's the sides of the triangle, right? In this case, it would be the adjacent over the hypotenuse. Would everybody agree? Okay. Well, what I need to do now, though, is find the angle. This 0.2967, that represents the ratio of 2 sides of the triangle. So what am I going to need to do in order to find B? And it's been a while. Ms. Stern did talk to you about this a while back. Okay, Aiden says to the -1. That means we have to take the inverse cosine. If you've got the ratio of the sides for the triangle and you're needing that angle measure, you're going to take the inverse cosine of that ratio. That's going to give me the measure of angle B. Okay. Just think about it. Normally, if I go ahead and take a trig function, okay, like cosine of an angle measure, okay, what I'm going to get out is the ratio of the triangle sides. Okay. Every time you evaluate a trig function, you plug in some angle measure, whether that's radians or degrees, and you're going to get out the sides of a triangle. Well, if we're working backwards, what we're doing here, I'm going to take the inverse, but I'm going to input the ratio of the triangle sides. And this time the output is going to be that angle measure that I'm looking for. Okay. Remember, think back to what we did when we were talking about inverses. We were taking the two quantities and what? We were switching them, right? Well, isn't that exactly what's happening here? Okay. Now, let's see. For that 0.2967, I rounded it just so I could have something to go ahead and put on my paper, because you remember you do want to show work, because in case you get it wrong, we want to be able to go back and see where you made your mistake. But now when I go to the calculator, just like we've done several times, go to trig. The second row is your inverse trig functions. I'm going to go ahead and use the actual value in the calculator. I'm not going to use the rounded version because I'm going to go ahead and get a much better answer. So what's the measure of angle B? Well, let's say about 72.7 degrees. Okay. So we had to use the cosine inverse to do that. 72.7 degrees. Okay. Now, the rule here, once you start the problem, if you've already found the largest angle, whether he's obtuse or acute, we are now free to either continue using the law of cosines, or we could just go back to the law of sines. What would you guys prefer? That's what a lot of people prefer to do, is go back to the law of sines. Okay, so let's do this. Let me take this off right here. So my pair now, I've got the sine of 72.7 over the 24.3 feet equals. Now, the ratio we set it equal to, well, that depends on what angle we want to find next. Do we want to find A or C? A, okay. So let's say we have sine of A over the 19 feet. And does anybody notice something that I'm also going to have to do here? There you go. Aiden said the inverse. If your ultimate goal is to get an angle measure, you're going to have to take the inverse. Okay, now, up till then, everything's still the same. I'm going to go ahead and cross multiply. So 24.3 times the sine of A is equal to 19 times the sine of 72.7. Divide through by the 24.3. So sine of A is equal to 19 sine of 72.7 all over the 24.3. Okay. So again, now that I've manipulated it to a certain point, I just plug that expression in the calculator. So let's see what that ends up being. Control divide. We have the 19 times the sine. And again, I'm not going to use my rounded version. That's 72.7. I'm going to go ahead and plug in that exact value that I previously had. And then this whole thing is divided by 24.3. Okay. Now this is what sine of A should equal. This decimal represents the ratio of those two triangle sides. Because we're going with sine, this would represent what we would know to be the opposite and the hypotenuse, right? Is everybody with me? Whatever those lengths are. Okay. So let's say 0.7467. So sine of A. So sine of A is equal to I totally blanked on the number. 7467. 0.7467. So now I've got the ratio of the sides of the triangle, but I want A. So I have to do what? Got to take the inverse. So I'm going to take the inverse sine of that ratio, and that is going to give me angle A. All right, so let's see what that comes out to be. So trig, again, the inverse functions are in the second row, and I'm going to use that previous decimal to help me out here. So I'm getting angle A to be about 48.3 degrees. Is that what you folks are getting? Okay, 48.3. That's a degree symbol. Okay. All right. Now, again, if I want to, for that last angle, I could use the law of sines. I could use the law of cosines. But what would just be really simple and really fast? Yeah, once you have two of the three angles, just subtract it from 180. I mean, if you can, but there's no reason to go ahead and do more work. So let's see, 180 minus the 72.7 minus the 48.3. And here, I'm more inclined to go ahead and use the values that we have. So I'm going to say 59. So angle C is 59 degrees. And there we go. That is the law of cosines. Questions? Okay, well, let's try another one. The next example says a triangular lot has sides of 120, 186, and 147 feet. Find the angle across from the shortest side. Okay, so let me go ahead and just draw a triangle. As long as it's not a right triangle, it doesn't matter how you draw it. Okay. So let's say we have our lengths here of 120. We got a 186, and then we have a 147. All right. Now, there's always an exception to a lot of the rules that we're going to go ahead and take a look at. Here, we are going to go ahead and use the law of cosines, but I'm not interested in solving the entire triangle. And we won't even have to use the law of sines on this one. How do I know which angle is going to be the smallest? It would have to be opposite the shortest side. So 120 being the shortest, I'm going to go with this guy right here. Okay. Now, just kind of, again, as an FYI, if I were asked to go ahead and solve this triangle for everything that's missing, all three angle measures, I would absolutely not start with this angle. Which one would I want to start with? There you go. I'd want to start with this one right here. Let's just go ahead and call him alpha, across from 186. That alpha, I know he's either obtuse or he's obtuse, because he's across from the largest side length. Okay, I would always want to start with him, but this one just wants the smallest, and the law of cosines will always give you what you want. Okay, so take about, let's say 30 seconds. Using the law of cosines, write me an equation that we could use to solve for theta. Okay, right, Xavier? Right, head up. Okay. And then, and if you feel really confident with it, go ahead and solve it. Okay, but right now I'm just looking for that equation. We're looking for the angle across from 120. Okay. Now, let me go ahead and catch up to you folks. You may not be done, and that's okay. I'm looking for this angle theta that we've identified as the smallest of the three angles. So because that's across from 120, 120 has to start my equation. So 120 squared equals, now what would I do with the other two side lengths? I'd have to square both and then do what? Add them. So 186 squared plus 147 squared. Now what? Minus 2 times the two side lengths. So 186, 147 times the cosine of the angle we're looking for. Okay, how many people set that up correctly? Okay, so not bad, not bad, okay. All right, now just as before, our goal is to solve for theta, so we first have to isolate cosine of theta. So the two individual terms, we're going to subtract those over. Then I'm going to divide through by that product. So I should end up with this, 120 squared minus 186 squared minus 147 squared, all divided by the negative 2 times 186 times 147. That's going to give me cosine theta. Okay, so let's see what that is. Document B out here, so control divide. Start with 120 minus the 186 minus the 147. And this is all over negative 2 times 186 times 147. Okay. I'm getting that cosine of theta should equal this. And if you want to go with the decimal, I mean, it really doesn't matter because we're about to take the inverse function. Okay. So 0.7645. Okay. So 0.7645 is equal to cosine of theta. Now, if I have the ratio and I want the angle measure, we have to take the inverse. 0.7645. That's going to give me theta. All right. Has anybody figured that out yet? Okay. So let me catch up to you. Cosine inverse of that decimal we just got. I'm getting about 40.1 degrees. Exactly right. Good, good, good. Okay, law of cosines. Any questions? Is anybody not seeing where I got any of these values? Okay. All right, now let me go ahead and show you something very quickly. This problem is not in your packet. I actually went ahead and came up with it this morning because I wanted to go ahead and prove a point to you. Let's say you have a triangle like this, side lengths of 9, 11, and 16. Okay? And I want to go ahead and find all three of the missing angles. Well, where should I start? Should I start with angle A, B, or C? Have to start with C. Because the angle across from the largest side, he could be obtuse, he could be acute. But either way, if I start with him, then I'm free to go ahead and use the law of sines after that. There won't be any problems. So let's start there. What would be my equation if I wanted to find angle C? Oh, no, I can't use the law of sines. Okay, so 16 squared should equal. Or, oh, hey, do you just want to go straight to the expression? If you feel confident with that, we'll do it. So it would be 16 squared what? Minus 9 squared, minus 11 squared, all over, equals the cosine of C. Good. And see, the more you do that, you're going to get more comfortable, and see, you just get right into that expression. Very good. So let's figure out what that is. Let's see here. Let me get rid of all this. So document B, we had 16 squared minus 9 squared minus 11 squared all over negative 2 times 9 times 11. Okay, so I'm getting negative 3/11ths for the cosine of C. All right. So that's the ratio of my sides. Okay, so now I'm going to take the cosine inverse. Cosine inverse of the negative 3/11ths, and that's going to give me C. All right, so let's see what we got here. Okay, so I'm getting 105.8. So here it's a really good thing we did start with C because he did turn out to be obtuse. Even if he's not, you just want to make sure. So 105.8. Okay. Now, whether C did turn out to be obtuse or whether he's acute, either way, what do I now know about A and B? They have to be acute. It's the only way we can form a triangle. So now let's go with the law of sines. Okay. So let's go ahead and find angle A first. So I'm going to say sine of 105.8 degrees over 16 equals the sine of A over 11. Okay. Now, can someone tell me what the expression for sine of A should equal? Once I cross multiply and divide. Okay. And Christian, what am I going to be dividing by? Okay. So I should have 11 sine of 105.8 all over 16. Would everybody agree? Okay. So now, again, I've written 105.8 because I'm giving that as my answer, but remember, I still have that value in the calculator. So I'm going to come on over here, control divide. So we have 11 sine. I'm going to go ahead and use that angle measure that we previously had. Again, I'm not using my rounded version. Divided by 16. Okay. So this is what sine of A should equal. 0.6614. Okay. So now how do I use that to figure out A? Got to take the inverse. Every time you want an angle measure, you have to take the inverse. Only if you want the angle measure. If you're looking for a side length, you will not be taking the inverse. Okay, so sine inverse of the previous. I'm saying about 41.4. Okay. So 41.4 degrees. Now, could I go ahead and use one of the two laws to find angle B? Yeah, but is it really necessary? If you got two of the three, just go ahead and find the missing. All right, so I'm just going to go ahead and use the ones I have. Minus 105.8 minus, what did we get here, 41.4? So I'm going to say B is 32.8. Now, B really isn't important for what we're going to go ahead and do in just a minute. So is everybody okay? Just like we've been working. Okay, nobody's confused about where any value came from. Okay, now let's say you had this exact problem, but you decided to go ahead and use the law of cosines for another angle. Okay, I've already got this worked down here. So let's say you did not start with the largest angle. Okay, well here's the thing, the law of cosines will always provide you the angle that you need every single time. So you can just use law of cosines twice, get your third angle from subtracting from 180, you're good to go. But again, what a lot of people like to do, once they use the law of cosines and they get a pair, they like to go back to the law of sines. So take a look. You'll notice I went ahead and solved for angle A first using the law of cosines. Well, what did I end up getting? 41.4. Isn't that exactly what we got here? Okay. Now what I did, not thinking about the fact that that angle C could be obtuse, I'm going to go ahead and now use the law of sines, okay, with that pair I just had. Sine of 41.4 over 11 equals sine of C over 16. Now, what did we get for C? Wasn't it 105.8? Didn't he turn out to be obtuse? When you solve here, look what I got. 74.1. But that's not just a random number. Does anybody notice it? Okay. Think about it. What are the three sums of the angles always supposed to give you? 180. Now, this is going to be slightly off, but if I take the 105.8 that we found plus the 74.1 that I just found, here's what's happening. The inverse sine function can only give you an acute angle. It cannot give you an obtuse angle. So if you go ahead and try to use sine inverse to find what turns out to be an obtuse angle, he's going to give you the acute angle supplemental to what the real angle should be. Okay? That's why you've got to be so careful. Sine inverse cannot give you an obtuse angle. Cosine inverse can. That's why I've been really, really adamant about pushing this idea. If you're going to use the law of cosines, start with what? If you always start with the largest angle, whether he turns out to be obtuse or acute, there is absolutely no problem with using the law of sines after that. You're guaranteed they should be acute. Is everybody okay with that? That's kind of the point that I was really trying to make. Okay. Alrighty then. Now I'm going to go ahead erase these for the next class. Okay, well, there was just one other thing I wanted to go ahead and show you, and then we were going to be done for today. Let's look at this problem right here. Solve triangle ABC. So this time I want the missing side length and the two missing angles. Okay. Round side lengths to the nearest whole number and angle measures to the nearest tenth. So again, you want to be very careful. Always be thinking about what you're doing. Okay. If I were going to work this problem, I would probably start with A. Let's find a side length. Now, if I'm finding a side length, do I need the inverse? Only if what? Only if I'm finding an angle measure do I need the inverse. Not if I'm looking for a side. Well, if I'm looking for side A, wouldn't he start my equation? A squared would equal what? Yeah, remember the other two sides, I'm going to take the sum of their squares. Then I'm going to subtract 2 times their product times the cosine of the angle across from the side I have. Does anybody notice anything different about this one? Yeah, isn't it already solved for what you're looking for? The only thing you have to do is just put everything below a square root. You don't have to manipulate this guy at all. Okay, so let's go ahead and plug him in and see what we get. Let me get out of here. So I'm going to put a big square root in there. So control x squared. Let's see, it was 12 squared plus, was it 14 squared? Minus 2 times 12 times 14 times the cosine. I want to say 39.4. Okay. So I know that side A should be 8.96, so we'll say what? We'll say 9. Okay. Now, let me ask you a question. Okay. We have a pair. I can use the law of sines. But there's probably one angle that I don't want to use that with. Would it be angle B or C? Why C? See, here's the thing. I now know the 3 side lengths of the triangle, so I know that C is going to be the largest angle, right? He could be obtuse. He could be acute, but we don't know. If he's obtuse, will the law of sines help me? No. So I would play it safe. I would go ahead and find angle B, and then you could easily just subtract those from 180 to find out what C is. Okay. In this case, I don't think it turns out to be obtuse. I think he turns out to be like 82 point something. Has anybody already solved it? Yeah, because for B, I think I was getting 59.7. Okay. All right. How are we doing? Any questions? Okay, here's what I'm going to leave you with today. The next part here, we're going to be talking about a special case, side-side angle. This is what we're going to be talking about tomorrow. But if you'll do me a favor, you still don't have any homework yet. take about 5 to 10 minutes, not even that, okay? Just look over this table, kind of foreshadowing what we're going to do tomorrow. So that when we come in, I just kind of walk you through the process, and we'll see how you guys think about it. Okay? All right. So thank you very much, guys. Good job.